Hello, my name is Liao XIUYA, and this is a presentation for Project Python Group assignment named Greenhouse Gas Emissions. And this is our team. They are Liao XIUYA, Rizki, Osama, and Omar. And there are some introductions about greenhouse gas emissions. We collect our dataset from Kaggle, and our dataset includes more than 8,900 rows of data. And this is content about our project. It includes four parts in our project. First, data cleaning, preparation, and wrangling. Second, data aggregation and group operations. Third, visualization. And the fourth, machine learning. And the tools we used in our project includes Python and Google Colab.
Hi, so basically in this slide, I will guide you through that our data cleaning processing. So first we start with raw data containing emission data from various countries and years. Our initial task involved dropping unnecessary column to simplify our analysis. Next, we handle any missing value to ensure data integrity. Then we also check the data type and converting year to numerical format for easier of analysis. By the end of this stage, our data is clean and ready to deeper insight. And also we can, after we cleaning the data, so we can drive a valuable insight. So we observe trend in global emission to understand if they are increasing or decreasing yearly. We identify which countries and region emit the most and the last, and helping us to pinpoint the area for focused environmental policies. Additionally, we analyze which industry sector contribute to emit. So moving to the objective of our project, so our main goal are to cluster countries based on their CO2 emissions pattern, analyze trend and predict future emission using line regression. We aim to assess the impact of environmental policy by examining historical data, providing makers with the insight needed to drive effective climate change mitigation effort. Our research question focus on understanding the emission patterns, identifying high emission countries, and evaluating the effectiveness of environmental policy in reducing emissions. So as we can see in these graphs, so basically the first chart shows the top 10 countries by total greenhouse emissions, highlighting the major contributors. And the second chart displays the trend of global greenhouse gas emission over the years. So we can see the peak around the mid of 2000s, following by the general decline, which could indicate the impact of global effort to reduce emissions. So these graphs are critical for communicating the scale of and impact of greenhouse gas across different region and years.
Here is the two graphs shows the top industry by total emission, and the right graph is the distribution of green gases emission in 2018.
Okay. Based on the report from the greenhouse gas emission or GHG, we can see that on the chart, the India is higher, significantly higher GHG emission than Argentina and also Brazil. At over 2.5 million metric tons of CO2, Argentina and Brazil have similar emission but still significantly lower than India. Now we talk about the top 10 countries with the CO2 emission multipliers. Based on the chart, we can see that Kazakhstan has highest rank with the emission of over 10 million metric tons, significantly higher than any other country on the list. which like do is coal-based energy industry and heavy industry sector. Country has Russia and also Saudi Arabia have highest emission, which can be attributed to oil and gas production. China and India, as country with large population, also show significant emissions, which might be influenced by industrial growth and energy consumption. Now we talk about the machine learning technique that we use or implement to this project. Actually, we implement two machine learning technique. The first one is key means clustering, and the second one is linear regression. For key mean clustering, we found that the result can be used to identify emission pattern across countries and help in the formulation of global environment policies. Countries in the same cluster can be future analyzed to understand the factors that influence their emission and also determine appropriate mitigation strategy. And using the linear regression, especially emission prediction for Argentina, we found that the linear regression model used in the analysis provides very accurate result in predicting Argentina emissions. It shows that the country carbon emission have experienced fairly steady growth over time. However, this model only captures linear trends and does not take into the account external factors, such as environmental policies or economic change that maybe affect future emission pattern. Therefore, for the long-term prediction, more complex methods such as non-linear regression or machine learning-based model may be need to be considered.
So, in conclusion, the clustering result can be found to identify emission patterns across countries and help in the formulation of global environmental policies. Countries in the same cluster can be further analyzed to understand the factors that influence their emission and determine the appropriate mitigation strategies. Argentina's CO2 emission trends appear very linear, meaning that the growth of emission over time can be predicted with a simple approach. There is no significant deviation between the actual and predicted value, indicating that the linear regression model is reliable in projecting future mission if this pattern continues. The linear regression model used in this analysis provides very accurate results in predicting Argentina's CO2 emissions. It shows that the country's carbon emissions have experienced fairly steady growth over time. However, this model only captured linear trends and doesn't take into account external factors such as environmental policies or economic change that may affect future emission pattern. Therefore, for long-term prediction, more complex methods such as nonlinear regression or machine learning based model may need to be considered.